So now we're on section 6, electrochemistry part 6, section 6, cell potential at non-standard conditions and the derivation of the Nernst equation. Okay, we can have, what happens when we're at not standard potential? We're not having a concentration 1 molar. Does that mean that I don't have, I can't create a battery, or I don't have any possible voltage? The idea is no. We can have a voltmeter reading, but we must do a correction to the E values, okay, or E naught values. If you remember, whenever we got the E naught values, we had put the zinc electrode by itself with the hydrogen electrode with the She, and the copper electrode by itself with the She electrode, and we got the E naughts for both the zinc couple and the copper couple. So we got the E naughts when we put them with the She electrode. Now, when we put zinc with copper, okay, we get a cell, and it happens to be a positive voltmeter reading, so it's a battery or a galvanic cell. It could be called a Daniel cell as well. Okay. Now, these concentrations are standard, 1 molar, and at 25 degrees Celsius is considered standard conditions. Now, if we take a different concentration of the zinc ion and a different concentration of the copper ion, 2 molar and 0.1 molar, 0.01 molar. It turns out that we also do a reading, a cell reading. But this cell reading, remember, how can I get this cell reading here? E of the cell, E naught cell. How did I used to get it?
A cathode minus A anode.
E naught cathode minus E naught at the anode. يعني E naught of the copper cell minus the E naught of the zinc cell. Clear? And we have E naughts, copper and zinc, so I could easily do the calculation, and usually the calculation fits directly the experimental E naught of the cell. Here, am I allowed to do the same thing, use E naught copper, E naught zinc, and get the E of the cell? The idea is no, I cannot use the E naught values. I have to correct the E naught values, okay, E naught of each, and make a correction and then get the E of the cell from the new corrected values. How do we do this? There's a huge derivation at the end for doing this correction. Now I'm going to go through this derivation very quickly, and in the end I'm just going to tell you, please just memorize this equation, okay? The maximum amount of work done by any galvanic cell can be related to the E of that cell. Okay, so work max is the work at the beginning of every cell, yani when you first turn on the cell, okay, that's the beginning, and that's what we call the work max of the cell, of the battery. يعني الباتري بتشتغل at its maximum at the beginning. And it's related to the potential E, okay, of that cell, multiplied by the free energy, or Q, okay? Q, nonetheless, is N number of electron transfer times the Faraday's constant. Okay, and this is the cell potential starts to drop as the electron starts to flow, and then eventually there's going to be a stop of the current where the battery is completely empty as we're using up all this work. When we have an open circuit, we have no flow of electrons. We have to close the circuit. That's when the battery really stops. Faraday's constant is the amount of charge in 1 mole of electrons. So this is Q, the charge, sorry, free energy. Q is the charge. This charge is per electron. So I multiply the number of electrons, N, and I will get the charge. Faraday is the amount of charge for 1 mole of electron transferred. So instead of Q, we're going to put number of electron transferred times Faraday's constant, giving me Q. Typically, the free energy of any reaction is the maximum work done on the reaction, and the work viewed from the point of view of the system. So if I'm looking at the system and I'm doing work, and that system is giving off energy and giving off work, okay, it's giving off energy, it's going to be negative. Always these guys are negative of each other. We know that for a process carried out at a constant temperature and pressure, the change in free energy equals to the maximum useful work obtainable from that process. Work flows out of the system is indicated by the negative sign. When you do work and work is coming out of that system, that means that it takes a negative sign. And so we substitute in and we get that delta G of the reaction, and the free energy is minus NFE. This is the first equation that I only want you to memorize at this moment, that delta G is minus NFE. So we related free energy to the potential of a cell. There's a relationship between thermodynamics and electrochemistry. We can relate the composition of a system, which is called the reaction quotient, okay, to the driving force of the reaction or the free energy. And this is a thermodynamic equation where the free energy is equals to the standard free energy plus RT ln Q, okay? RT ln Q, and this is a relationship then between free energy and the composition of any reaction. When the concentrations are 1 molar, that means that the composition of the reaction Q is going to all be 1, and ln of Q will be 0, and therefore the delta G of the system is simply equal to the free energy at standard conditions, not. If we relate thermodynamics to electrochemistry, this is simple thermodynamics at this point. Now we're going to relate thermodynamics to electrochemistry. We already derived that delta G is equal to minus NFE. As well, delta G naught then standard is minus NFE naught. If we go here and substitute into the thermodynamic function with the relationship between the electrochemistry and free energy function, then we get minus NFE equals minus NFE naught plus RT ln Q. يعني مطرح الدلتا G حطينا هاي ومطرح الدلتا G naught حطينا هاي. That's all I did. We divide by NF, we get E equals E naught minus RT NF ln Q. Any ln function, ln of x, if I want to change it to a log function, I must multiply the log function by 2.303. This is mathematics. Don't worry about it. If we're at 25 degrees Celsius and the R is the R constant is a relationship between joules, the free energy, we're looking at this R constant, the free energy R divided by mole per Kelvin, not the free energy, the energy per mole per Kelvin, how much energy is exceeded, yani comes out per mole per Kelvin. Faraday's constant is the charge per 1 mole of electron. Then if I substitute these numbers in, because these do not change at constant temperature, الN بتتغير, الF ما عم تتغير. So this times that becomes 0.0592 divided by N, log of Q, and Q is the composition of the reaction products على reactants مثل ال K. And I want you to memorize and forget everything I said before, and I just need you to memorize this equation. This equation is called the Nerst equation. What is the Nerst equation? The Nerst equation literally is a correction value for the E naught values, corrected using a term that is going to be subtracted from the E naught, relative to the Q, yani composition, which is not 1 molar. So anything which is not 1 molar, the E naught must be corrected, and now we call it the E for each couple. So any couple, I can correct their E naughts, and the overall reaction as well, I can get the E for the overall reaction, knowing the E naughts. Okay. So the potential of a cell or the couple depends on the reaction quotient, yani at any concentration. And therefore, I can get the E of the couple at any single concentration. And then I can get the E of the cell. So we used to, this Nerst equation is used to correct the effect of non-standard conditions on the cell EMF. When the concentrations are at equilibrium, what do we mean by at equilibrium? Remember, at equilibrium, Q, the composition, is going to be the same as K at equilibrium. This is when we have Q equals K, we're at equilibrium. So delta G, what happens to the delta G when Q is at equilibrium? When this Q is equal to K, the free energy, the reaction actually stops. And the driving force for the reaction at equilibrium, there's no driving force for any further chemical change. Because I reached equilibrium, خلص, يعني I no longer need any energy to go forward or backwards because I'm happy I reached equilibrium. So كلمة equilibrium, it also means that delta G is 0. So if I go back here and I put delta G equals 0, and I put instead of Q, K, and I solve, I get that delta G naught equals minus RT ln K. This is a relationship that I also need you to memorize, that when we have reached equilibrium, the standard free energy, not the free energy is 0. The standard free energy equals minus RT ln K. We will use these two equations a lot throughout the process. There's a huge relationship between thermodynamics and electrochemistry. يعني هون في big شرح منين اجت W equals minus Q E max or minus W Q max. Always just know that the cell does work, so that work is negative if the cell itself is doing work. And always the cell is doing work at maximum. Whenever we say W, we really mean the maximum work of any cell, which is at the beginning of the current movement, okay? At the beginning of the current movement. You can go ahead and do all this reading if you want to know more details about the battery and its functioning and how it gives off energy and things like that. You can sit there and go ahead and do that reading. All right. Okay. So what does the electrode potential depend on? Yes, it depends on the nature of the electrode, which gives me the E naught values. That gives the nature of electrode. It depends on the concentration of the solution, yes, because now we can have corrected E's, which can vary with E naught minus 0.0592 على number of electron transferred log of Q حسب ال concentration of each solution. And it also depends on temperature. Now, in this case, هيدا الرقم, I already put the temperature at 25 degrees Celsius, or else this number is different. Okay. The couple is not at standard state. We use the reduction potential E ox على red, not E naught. E naught means standard potential. E is non-standard. E and E naught are related by the Nerst equation. Okay. Find the electrode reduction potential at non-standard conditions. Let's go ahead and just start with these equations, okay? بحبش الفرنش system that is always, بحسه بس look of it معقد. إنه عنا ox n electrons alpha prime red هون عندها alpha بالأول and E is E naught minus 0.0592 divided by n log of the activity of the reducing agent divided by the activity of the oxidizing agent. This is to the alpha prime and this is to the alpha. يعني just looking at it looks so confusing when it is so simple. Okay, and I'm going to show it to you directly how simple it is. Get a couple, a half reaction, okay, in the form of a couple. So عندنا copper 2 plus 2 electrons goes to copper. Always and not necessarily, but this happens to be a 1-to-1 mole ratio. If I wanted the E of this copper 2 plus copper couple, what do? First, I let it equal to the E naught of the copper 2 copper minus, this is the real correction, if in case this is different than 25 degrees, but at 25 degrees, this is minus 0.0592 divided by N, where N is the electron transferred. So what is it here? It is 2 log products على reactants. Products, anything solid is simply 1. على reactants, it is copper 2 plus. And they always say that this is ox على red with a plus sign. Why do we use a plus sign? In a minus sign, it's reductant على oxidant لأنه product is always the reductant and the reactant is always the oxidant. So product على reactant, we use a minus sign. If I have a plus sign here and I switch this to a plus sign, that why is because this sometimes is easier when this copper is to the top. And so then I put oxidant على reductant. What do you want to use? It's really up to you. The original Nerst equation is in terms of the negative sign. You can leave it negative وبتصير واحد على الcopper and then switch it to a positive and then حطوا الcopper to the top. Or automatically you have to think إذا أنا بدي reactant على product, okay, then the sign switches so it becomes a positive. Okay, now you're going to help me do this. Anything solid has what? Has a concentration, if you will, of 1. يعني ما بنحط لها شيء. Okay. تلاقي 1. Let's look at this example. Okay, and let's do the reduction potential relative to the standard. Okay, correct. So let's do this. يلا ساعدوني. Everybody. What will be the E for the couple? This is already written in the reduction. لاحظين, it's written as a reduction. For the couple, mercury chloride, هحطها هيك على mercury. Okay. Which is like having mercury 2 plus على mercury. But because it's a solid, هيدا الsolid ما حفككه، خليها mercury chloride على mercury. It doesn't matter how you name the E. Okay, that. What would that be? First part. Everybody.
Sure, E, mine.
The E node or E, okay, standard of the mercury chloride على mercury. شو رأيكم أفضل حط minus or plus sign هون؟ بيجي بتطلع guys. إذا بتحسوا إنه الsolid is on the product side حطوا البلس. إذا الsolid is on the reactant خلوها in terms of minus. 0.0592 or دايما استعملوا الماينس sign or دايما استعملوا البلس sign. إذا plus sign reactant على product، إذا minus sign product على reactant. أنا دايما بفضل الماينس لأن دايما معودة product على reactant هي الكيو. product على reactant. log. Now 0.0592 على number of electron transferred, which is 2 log. Products على reactants. Okay, so what's the products? يلا. Come on.
We have only Cl minus, concentration Cl minus squared لأنه في حدا coefficient 2.
Exactly. We must put the coefficient to it. So that's the squared. That's what they're talking about, the alpha here. Okay, these alphas, يعني that's the coefficient. So it's the concentration squared. What about liquids? What about liquids? The liquid, okay, is not included or typically بحسبها already هي 1 molar unless stated otherwise. Okay, but usually liquids and solids are not included by any equation. We only include aqueous and gases. Okay, so liquids and solids are not to be included. Any questions still here? Let's do, all right. عامل لي animation هون بس يلا. Here. Yeah. دغري الإي شو بتطلع؟ الإي of the Cl2 Cl- becomes E naught Cl2 Cl- minus أنا دغري automatically أنا بحط الماينس 0.0592 على 2 log come on guys log
Cl- square. هلا الجاز شو بعتبرها؟
Cl- squared لأن عندنا 2 and we must include the gas pressure of Cl. We must include the gas. Okay, it must be included. Clear? And it's a bit odd إنه بياخد concentration units of, atmosphere. Okay, the pressure in gas, we put it in atmosphere units. بس too bad هي المعادلة يعني هون بالمولر تطلع molar squared really units على atmosphere بس regardless that's how it's done. Okay, let's look at this electrode. Okay, it's a platinum plate. So yeah, let's do the E. E become, come on. E of what actually? E of the chromium 2072 minus. Again, the first thing I have to do is write the equation show as a reduction reaction. So always electrons is on the right hand side. Okay, that's the first. And make sure that it's a balanced equation. No matter what I have, I must have a balanced equation. وهيدا شيء لحاله. E of the chromium 2072 minus oxidant على reductant على chromium equals the E naught of the chromium 027 على chromium. Now, because guys, we are MCQ كإكزام, انتوا ما حتجوا تكتبوا هاي, انتوا خلص حتقولوا E equals E naught minus 0.0592, okay, divided by, how many electrons are transferred?
Six.
How many? 6. Log what? Product على react. Okay. Product على reactants. يلا مين اللي products?
Cr3 plus.
Cr3 plus, so concentration of Cr3 plus to what? Does it have a power?
Squared.
Squared. How about the water?
I do not include the water in fruit, huh?
Do not include the water into this equation. In the equation it's included, but into the Q it's not included. Divided by. يلا.
CR207.
minus.
Cr207 minus. Does it have
No problem.
a ratio here? No, it's 1. Okay. What else?
Multiplied by H3O plus power 14.
Okay. I must include the acid present. or the OH is عندي balance equation يا بيكون عندي H plus or OH minus or H3O plus أمرار. Okay, so you must include it into the reaction to the power 14, whatever its power is. Clear? Okay, so the first thing I have to do if I have any cell is first, if the concentrations are not standard, I need to get the new E. The new E of each electrode in the cell, and then I say E cathode minus E anode. Okay. بس هون point. Okay, so watch out here sometimes إذا بتشوفوا H plus or H3O plus هي نفس الرقم بضل، لأن أنا بكون عم زيد H2O 14 واحد، بس بيختلف هو الووتر. So watch out when we're balancing equations. If they have H3O plus, that means I have to add water to both sides. So the number in front of the water might change. Okay. وهون بتصير 17 زائد 14. Okay. The Q doesn't change at all because this is the same. Calculate the potential E for the iron 3 plus, iron 2 plus electrode at 25 degrees Celsius when the concentration of iron 2 plus is exactly 5 times that of the iron 3 plus. So they gave you the E naught values. وبدنا the potential of this couple where one of them is not, 5 times the concentration of the other. So the reduction half reaction here, iron 3 plus plus 1 electron goes to iron 2 plus. We know that E equals E naught minus 0.0592 and log of Q. E naught is 0.0771 minus 0.0592 divided by 1 log of products على reactants or reductant على oxidants because I have a negative here. Fe2 plus على Fe3 plus. What did we have? We have the fact that Fe2 plus is 5 times bigger than Fe3 plus. So the concentration of Fe2 plus is 5 times that of Fe3 plus. And so if I substitute محل Fe2 plus 5 Fe3 plus, then I don't need an exact original concentration for any of these ions. They will be eliminated and we solve, and now it's a matter of calculator. And yeah, wait, من calculators, okay? Are we clear? And you just get a new E, whatever it is. Okay, so now if we want to determine if a reaction is spontaneous or not, we must use E and not E naught values. Okay, هلا you will learn that E naught values and E values are very close to each other. يعني ما كتير النيرست equation الconcentration بيتغير. You will see that there isn't that much of a difference. And this is pretty much why, for simplicity and speed in solving, sometimes you can tell if a reaction is spontaneous or non-spontaneous directly by using E naught values and not necessarily having to get first the E values for each electrode and then deciding if it's spontaneous or not. وهيدي تريك بدي إياكم تستعملوها. إنه a lot of times, if I just want to know if something is spontaneous or not, even if I'm not in standard conditions, I can simply use E naught values and decide if the reaction is spontaneous. لأنه it takes a while to solve for the Nerst equation for each couple. and then put them on an E diagram and then decide if the reaction is spontaneous or not. Always, the overall spontaneous is the strongest oxidant reacting with the strongest reductant in the reaction, and we do have to, يعني, idea. Okay. Will the following reaction occur spontaneously when the concentration of iron is this much and cadmium is this much? Okay. So they gave you already the reaction. Are we in standard state? Help me out, guys. Are we in standard state?
No, because the
No, we
chemical
are not minus 0.1.
Exactly, we are not. We don't have 1 molar. Okay. So if I want to know if something is spontaneous or not, I have to get the E, okay, for the overall reaction, or E of each of these couples. Okay. First, under standard conditions, best for a moment, they gave us, or they should have at least, we should get the E node of the iron and the E node of cadmium. معي لهون. And it's not really up to me because they already gave me the reaction. هون usually خليني أنا أحكي لو أنا بدي أختار الرياكشن. If the E node of iron is minus 0.04, so iron, the E node of the iron, ما راح أحطهم ككابل, minus 0.044. Well, E node للcadmium is minus 0.40. Usually, if you had to choose just directly from this, who will be the oxidation and who will be reduction? Who would you choose as the oxidation half reaction, and who will you choose as the reduction half reaction?
Oxidation was the lowest negative?
The lowest negative is the oxidation. So who will be the oxidation, iron or cadmium?
F iron.
Iron. Heidi, if I had to choose, صحيح? This is less negative. So more, okay, it's less negative, so it should undergo reduction. This is more negative, so it should undergo oxidation. Is that the case in this equation? Let's see. What's happening to the Fe? So I'm going to split the equation. Fe2 plus goes to Fe.
دكتور مش مغلطة أنت؟
Cadmium goes to cadmium 2 plus. هاي بالإيكويشن اللي هن عطوني إياها. Okay, صحيح? So let's solve plus 2 electrons, and here you have plus 2 electrons on this end to balance the electrons. And so what is happening is in this equation as given, the iron is undergoing reduction while the cadmium is undergoing oxidation, يعني opposite to
يعني
what
not spontaneous مفروض.
you might choose. Okay, so E node is the reaction is like this, and أنا مش عزوقي, reaction is already given to me. So مش عزوقي أنا اختار هوني who's oxidation, who's reduction. The reaction is telling me that iron is the reduction and cadmium is the oxidation. So from the equation, the E of this equation, E node, لو node, is E node of iron minus E node of cadmium is minus 0.04. Is this spontaneous under standard?
No, under standard, no.
Under standard, it is not.
Spontaneous.
It's not spontaneous. Okay. What do we have to do? We have to get the
دكتور هي مش اللي نيجاتيف بتكون الاكسيديشن.
نيجاتيف. هن اثنيناتهم مسايبين نيجاتيف. لما يكونوا اثنيناتهم نيجاتيف هي المور نيجاتيف لازم تكون اوكسيديشن. يس.
اوكي.
اذا كانت spontaneous. بس هن كاتبين لي اياها بطريقه non spontaneous. So حطوها a big thing in your mind. If the reaction is already given, it's not up to you to choose. You have to see who is the reduction and who's the oxidation. Okay? It's not up to you. Are we clear?
Yes.
Okay. So, as written, they have chosen like this. Too bad they have chosen it non-spontaneous under standard conditions. But we will see if this reaction is really spontaneous or not. Already the overall reaction is given, guys. And I have two choices with how I do this. I either use the Nerst equation for the overall reaction, or I get the E for the Fe by itself, E cadmium by itself, each corrected, and I want to prove it to you that I'm going to get the same thing. Now, let's correct each electrode لوحده. Okay. E للFe هي ال E naught للFe minus 0.0592 log. Remember, when I get reduction potentials, these are also reduction potential. Yani, even if the reaction is undergoing reduction, oxidation, I use the reduction half reaction. And therefore, so I have here, this is reduction written in the reduction way. So it is plus Fe2 plus concentration. ليش حطيت بلس؟ لأنه أنا بلا ما أحط واحد على Fe حطيتها بلس وحطيت Fe. معي أنتو؟ الكادميوم, it's E naught of cadmium, couple, 0.0592, sorry, I divided by 2 electrons, and there's 2 electrons transferred. Cadmium كمان divided by 2 electrons, log. بدي انتبه, هيدي as written هون مكتوبة بطريقة oxidation. أنا لما بدي حطها هون بهاي الإيكويشن, it must be in the reduction form. So كمان plus concentration للcadmium. Let's solve for this. هيدا شو بده يطلع الرقم؟ minus 0.44 plus 0.0592 على 2 log للFe. الFe قد ايه كانت الكونسنتريشن؟ 0.6. يلا solve it for me somebody please. Get me a number. للE للFe. هيدي minus 0.40 plus 0.0592 على 2 log قد ايه الكونسنتريشن للكادميوم؟ 0.01. Okay, so here I got the reduction potential of each electrode, إذا كانوا electrodes, of each electrode بهالreaction separately. Okay, what did you get for the E of iron? حدا جابها؟
طلعت minus 0.4465 شيء.
0.446 مش negative؟ اوكي وهيدا
ثانية واحدة.
minus yeah
minus 0.45.
minus 0.4592.
4592.
45, 19, 19.
92.
Okay, 459. Okay. I just want to, are you sure? Huh? Can
أنا
somebody
كمان
redo
هيك
this?
طلعت معي.
Okay. So I want you to look. لاحظين مش فارقين كتير، يعني انه مش فارق، يعني فارق بس مش انه والله صار plus or something، بعده قريب 0.45 0.446 مش كتير فارق. But there is a difference. Let me now get E of this reaction. E of this reaction. بهيدي الرياكشن اوكي اللي هي السل، مين الكاثود؟ مين الريدكشن؟ الايرون هي الريدكشن. مين الاكسيديشن؟ الكادميوم هي الاكسيديشن. اوكي so minus 0.446 minus that of cadmium, a negative 0.459. What did we get? The E of this reaction?
0.013.
0.013. Okay. So what did I do here? I did each electrode by itself, or each couple by itself, the reduction potential of each couple, corrected using the Nerst equation because I have different concentrations than 1 molar. Then I got E of the reaction, depending on the reaction, who's the oxidation, who's the reduction. E reduction minus E of the one undergoing oxidation. And I got the E of this reaction. شو طلعت؟ 0.013. I want to show you that if I had used the Nerst, where I put Q here for the overall reaction, and E is E of the cell, يعني E cathode minus E anode لحال. بجيب I solve it, E cathode minus E anode, or E reduction minus E oxidation لأنه منا it's a reaction, so E reaction, E node. E reduction minus E oxidation شو طلعت minus 0.04. Minus 0.0592 divided by the overall number of electron transferred. This is 2, this is 2, so it's fine. Log of the products على reactants. طيب بجي للإيكويشن. شو الكونسنتريشن للكادميوم هون؟ 0.01 وهون 0.6. So it's the products cadmium على reactant Fe2 plus, and I solve for this. Look at what I get, 0.0126, which is, if you want to actually put it to two significant figures, هي نفسها 0.013. And so net, erase. If you find a reaction, and they gave you a reaction, and you want to find the E of this reaction, then find the E node of the reaction by finding out who's going to undergo reduction, who will undergo oxidation. Get the E node first, and use the Nerst equation for the overall reaction, where Q is products divided by reactants for the overall. And I find this easier than finding each of these separately. Are we clear? Is this reaction spontaneous? Yes, it is. As long as the E is greater than 0, for these conditions, under these conditions, this reaction is spontaneous under non-standard. It was not spontaneous under if they were standard conditions. So if I ask you if a reaction is spontaneous or not, you can't just simply decide depending على ال E naught value that it's negative. You must get the E, and طالما ال E is greater than 0, then the reaction can be proven to be spontaneous or not. So really you cannot use simple E naughts to determine spontaneity unless it is really standard conditions. Calculate the potential of each electrode in the following cell and indicate the reaction that would occur spontaneously if the cell were short-circuited. Okay. What do we mean by short-circuited? Just يعني you put a short circuit, يعني decide you started the circuit. Okay. We want to decide if the cell is spontaneous or not.
دكتور بس عندنا لايف على 11:40.
Sorry. هذا فاتح شيء. Guys.